Hey everybody, welcome to Metal Oxide. We're going to go ahead and jump right in. In this actual lab, we're going to work with empirical formulas. If you have questions about that, there are videos for you. Make sure you reach out and let me help you, okay? So let's just jump right in. What we're going to do, let's see. What does a molecule include? Let me try that again. What does a molecule include? Well, basically, what we're looking at is two or more atoms that have been chemically combined. Two or more atoms that have been chemically combined. A chemical formula that indicates how many of each type of atom are present in a single molecule is referred to as a molecular formula. A molecule of ammonia contains one nitrogen atom and 3 hydrogen atoms. This is the molecular formula. What you're seeing right here is the molecular formula of that. What we're looking at is there's our nitrogen. The nitrogen does not have a subscript. Excuse me. The nitrogen does not have a subscript. It lacks the subscript on the N symbol, and that indicates that there's one atom of nitrogen in your molecule of ammonia. Now, the hydrogen, on the other hand, has a subscript of 3 below the symbol. That means that there are 3 hydrogen atoms in a molecule of ammonia. Another type of chemical formula is an empirical formula. An empirical formula will show the elements in a compound in their lowest whole number ratio. Now, this is glucose. Glucose is a simple sugar that cells use as their primary source of energy. You'll see glucose represented a lot in chemistry because it's everywhere, right? So the molecular formula for glucose is C6H12O6. Now, because each element that you see, the subscript for each element is divisible by 6, the empirical formula is 2O. That's the empirical formula. It is reduced. So if we go back here, we see that each one is divisible by 2. We divide it by, divisible by 6. We divide it by 6 and we come back with CH2O. Now, when chemists analyze an unknown compound, often the first step is determine its empirical formula. There are many compounds whose molecular and empirical formulas are the same. If a molecular formula cannot be simplified into a smaller whole number ratio, which is the case here with your H2O and your P2O5. Now we're going to talk ionic compounds. Ionic compounds are different than molecular compounds. Water and other molecules exist as collections of individual molecules, while ionic compounds do not exist as discrete molecular units. Ionic compounds consist of large 3D array of alternating positive or cations and negative or anions, okay? Positive ions, which are cations, and negative anions, which are, negative ions, which are anions, okay? So if we want to talk about sodium chloride, this is just an example. Sodium chloride is composed of a whole lot of sodium, and chlorine or chloride ions, and they're arranged into a structure just like this. So large array 3D structure. The formula for ionic compounds is always an empirical formula because it shows the smallest whole number ratio between the cations and the anions. Now, the actual number of ions in a sample of an ionic compound will be very large and will vary from sample to sample. This is just a general guideline to help you see the difference in molecular compounds and ionic compounds. We have characteristics that are considered to be molecular compounds and characteristics which are said to be ionic compounds. I would recommend to you to get familiar with this so that you might be able to understand the difference between molecular and ionic just by looking at the compound itself. All right, so let's talk about writing formulas for binary ionic compounds. The first thing we're going to do is we're going to write the metal ion and its charge. Then we're going to write the non-metal ion with its charge. And then finally, we'll decide how many ions of each type are needed for them to be neutral. If we consider the compound aluminum nitride, I just want to show you this periodic table. We're going to play with the periodic table a little bit. The charges on each of these ions can be determined by looking at the groups where they're located on the periodic table. Now, since these ions have charges that are equal in magnitude, which is 3, but different signs, one is positive and one is negative, you end up with a 1-to-1 ratio. And the 1-to-1 ratio is the lowest ratio of ions that will produce a neutral compound. 1-to-1. That is our lowest number. So let's just talk about aluminum nitride. Since the charge on aluminum is 3 positive and the charge on nitrogen is 3 negative, the sum of their charges is 0. And as a result, the formula of aluminum nitride is ALN. All right, so we have another example. In this case, we have 2 lithium ions, each with a 1+ charge, and they're required to balance out the charge of each oxide ion, which is a -2 charge. So you have a charged element. The formula of lithium oxide is Li2O, right? Because the compound must be neutral. So for compounds in which the ratio of ions is not as obvious as an alternative, you can use the crisscross or crossover method. The numerical value of each charge crosses over to become the subscript of the opposite ion. The signs of the charges are dropped. And that's what we're looking at here. From the 2 negative charge will cross over to become the subscript for Al. And the formula for aluminum oxide is Al2O3. The formula for this compound, the crisscross method, directly produces the correct formula, but that is not always the case, okay? Ionic compounds are always described by their empirical formula. Always. They must be written as the lowest whole number ratio of the ions, and a second step can be performed to reduce these subscripts. So you have a PB4O2 negative. You use the crisscross method. Your PB is now a PB2. Your oxygen is a 4, but those can be reduced if you take them into 2, and if you divide each one by 2, PB cancels into 1 and O is a 2, and that's how those work out. So let's just talk about how to write formulas for ionic compounds with polyatomic ions. Now, writing the formula for compounds with a polyatomic ion involves the same steps as binary compounds, but parentheses are used around your polyatomic ions. So if we're talking about calcium nitrate, the charge is balanced by the presence of 2 nitrate ions and 1 calcium ion. But the parentheses are used around the nitrate ion because more than 1 polyatomic ion is needed to neutralize a charge. Now what we're going to do is the crossover method or crisscross method. And that's what we come up with, right? Your Ca is now 1 and your NO3 is now 2. And that comes from your crisscross method. So again, parentheses are used around the nitrate ion because more than 1 polyatomic ion is needed to neutralize the charge. If only 1 polyatomic ion is present in a formula, you don't need parentheses. That's the beautiful part of it. This is a tool to help you remember what kind of compound has what function. This makes it a little bit easier when we go to name the compound. You're going to find this in the content section of your D2L under handy chemistry tools to have, but you can also just take a screenshot here and put it in your notebook. It's just a handy tool. You can print it out, have it in your notes while you're studying. If you bring it to class, print it out, you could find yourself in a bonus point situation. So that's all we have for metal oxide. Be sure to reach out if you have questions, watch the procedural video, and I look forward to seeing you guys in class.